Hey guys, Miss Davis here. If you're watching this, it's Unit 11, Skill 6. So our essential question today, how can I use z-scores to find probabilities? So last video we used z-scores to calculate and find basically how far away a given value is from the mean or from that central point in a set of data. So just some recall off to the side. If you want to write this down or if you remember it from yesterday, a z-score is just the given value minus the mean divided by the standard deviation. Okay, so example 1 talks about a swimmer named Amy, specializes in the 50-meter backstroke. In competition, her mean time, so her mean time for the event is 39.7. So that's like that's her average seconds, and the standard deviation of her times is 2.3 seconds. Okay, so it deviates by 2.3 seconds, assuming that Amy's times are approximately normally distributed. Okay, so normal distribution curve, we want to start off by drawing a picture, which is very important to do this and understand what you're finding. So we're going to draw our normal distribution curve, which is symmetrical. Okay, that does not look symmetrical. Hang on. So we go down, up, down. Okay, so down here, you always want to put the mean in the middle. So our mean is 39.7. Okay, and her standard deviation is 2.3, which we're going to use in the formula. But for right now, let's read through the question. Find the probability to the nearest hundredth that Amy's time is between 37 and 42 seconds. So, the mean is right in the middle. We know that we're going to label on here the other two given values that we're trying to find the probability between. So 37 is somewhere over here, and 42 is somewhere to the right of the mean. Okay, so we're basically finding the probability that it's somewhere between here and here. So we're going to end up with a probability or a percent chance that her time would be between those two values. So using our z-score formula, we're going to find the z-score for 37 and for 42. So over here we're going to do the z-score for 37 first. So z is equal to, again, it's the given value, so 37 minus the mean, which is 39.7, all over the standard deviation, which is 2.3. Okay, and I would just encourage you to type that all in your calculator, hit enter, and you end up with negative 1.174. Okay, so down here we get negative 1.174. Now it's negative because that means that that time is deviating to the left 1.174 standard deviations from the mean. Okay, so that's for 37. Now we're going to do a second one for our second value. That is 42. So for 42, let me just kind of move my paper over here. There we go. So we're going to take our given value of 42 seconds, subtract off the mean, which would be 39.7, and divide by the standard deviation again. So divide by 2.3. And this time our z-score, subtract and divide, is a perfect 1, which means that 42 is exactly 1 standard deviation to the right. And if you think about it, 39.7 plus the standard deviation of 2.3 brings you up to 42. Okay, so we got our two z-scores, but we're not finding the z-scores just to find them. We're using them to find the probability that her time is between these two. So what we're going to find next is the probability that her z-score is between, or sorry, that her time is between these two values. So I'm going to write this as negative 1. You put the smaller one first, then you put the z in the middle, leave a little bit of room there, and then 1 on the end. And then you want to put these less than symbols between each of the values in z to show that z is between negative 1.174 and positive 1. Now how do we do that? Well, we're going to do this using our calculator. And I'm going to go through the steps with you off to the side, and then I'm going to show you a quick video on how to do that with the graphing calculator in class. So in order to find this by hand, or using our calculator, the first thing we want to do is add a calculator. So step 1 is to add a calc. So regular calculate screen. Step 2, you're going to choose menu. Step 3 is going to be choose 6, which is statistics. Then step 4 is you're going to choose choice 5, which is distributions. And then the 5th step is you're going to choose choice 2, which is the normal CDF. Okay, so you're always choosing 2, not 1, normal CDF. So those are the steps. Now I'm going to insert a video to show you how to do that, and you're going to be using these numbers here. This is going to be your lower bound. The smaller one is your lower bound, and your larger one is the upper bound. Okay, and you'll see exactly what I mean in a second. All right, so for example, 1 part A, if you are trying to find the probability between two z-scores. So go ahead and add a calculate screen, and then on here you're going to choose menu, go down to number 6 for statistics, go down to number 5 for distributions, and then we're always going to choose number 2, the normal CDF. So normal curve is what we're working with, and CDF is the one that you always want to choose. Our lower bound for this one will always be the smaller number, so negative 1.174 from your notes, and your upper bound z-score was 1. And then these two things you never want to change, just leave them as what they are, and then hit OK. And what it calculates for you there is the probability, so 0.72 rounded to the nearest hundredth, 72% chance. All right, so that's your answer for the first part. All right, so after you type those in, you write it as 0.72 as your probability, which should tell you that that's a 72% chance that her time will be between 37 and 42. Okay, next example, same problem. Find the probability to the nearest hundredth that Amy's time in her next race is between 42 and 45 seconds. So now this time we're going to go ahead and sketch out that bell curve again. So, boop, boop. And always putting your mean in the middle, so 39.7 in the middle again. And then our two numbers are 42 and 45. So 42 is somewhere over here, and 45 is somewhere down there. Okay, so we're finding the probability that the score, or her time, will be between here and here. So we're finding really the probability between those two numbers in here. Sorry for the scribble there. So we want to find the z-score for both of these numbers. So we've got a z-score for 42 and a z-score for 45. Okay, so we've got z equals your given value, so 42 minus your mean, 39.7, divided by the standard deviation of 2.3. And when you type that guy in, hit enter, you get a perfect 1. And then for 45, we get z equals 45 minus 39.7 all over 2.3. Type that in, and we get 2.30435. Okay? All right, so next step is you're finding the probability between those two things. So the probability between our lower bound is 1 less than z less than 2.30435. Okay, so type that into your calculator as this being the lower bound here and the upper using those calculator steps, and you will find out that when you do that, you're going to end up with a 0.15 is your probability, or a 15% chance. Okay, so looking at the picture, does that kind of make sense that this would only be about 15? Okay, so next example, part C, we've got find the probability to the nearest hundredth that Amy's time in her next race is more than 45 seconds. So this time, which means at least 45 seconds. So if it said that her time is at least 45 seconds, that's the same thing as saying 45, more than 45. So just something to kind of note that more than 45 means that it's 45 or more, or higher. Okay, so when we think about this graphically, we've got our normal bell curve. We've got 39.7 in the middle again, and then this time we've got 45, which is out here. Okay, so 45 is headed towards, the tail on the right-hand side here. So we're actually finding this amount here, and it goes out to infinity. It never actually touches the ground there. They're the bottom of the graph. So we have to figure out what percent chance is it that she would have her time be more than 45 seconds. So we're only finding one z-score for this because we're only given one number. So the z-score is going to be equal to 45. Well, we already did it up above. So let's just kind of write it out again. Divided by your standard deviation. And that one ends up being 2.30435 as we found above. So now this time when we write it out as a probability, there's no end here. So it's really out to infinity. But what we're going to write it as the probability of, this is going to be our lower bound. Right, because 45 seconds is really the lowest we want for this problem. So it's going to be 2.30435 is less than z. But in this, when we plug it in, we're going to do and use as our upper bound a number that, like the largest number we can think of, 9, just write a bunch of 9s, 9. You know, a lot of them all at once, just to show that it's a really, really, really big number. So when you type this into your calculator, this will be your lower bound, and if you're doing infinity as your upper bound, this will be your upper. Okay, so here's a little video to show you how to do that. Now example 1 part C is what we're going to do here, and we're doing one that has a lower bound of the 2.3 z-score, but there's no upper bound because we're saying more than a given amount is an infinite endpoint there. So I'm going to go ahead and go back to your calculate screen, hit menu, number 6 for statistics, 5 for distributions, and then number 2 again for normal curve. And this time our lower bound is the minimum there, 2.30435, and then our upper bound is infinite, so infinity and beyond. We're going to type in a bunch of 9s there, okay? And then scroll down, leave those the same, and hit OK. All right, so now I've got 0.01, which is a 1% chance, and that's that. Alright, so for this example, this is a continued example from the previous page. It says, what is the probability to the nearest hundredth that Amy's time would be at most 45 seconds? When it says at most, that means 45 or less. Okay, so it's kind of the opposite of what you think when you see the word most, but it's 45 or less is at most. So let's think about this again as on our bell curve. So we've got, here's our curve, and our mean in the middle, 39.7, and 45 or less would be out here again, so 45 or less. So we're shading in this way. So it's all this, all this, all that, okay? So when we think about this, we have to use the z-score again. So we've got z-score with our value of 45 is 45 minus our 39.7 over our standard deviation of 2.3. And I believe this was the same from the previous page, is 2.30. Okay, so what we want to find is the probability that the z-score is less than the 2.3. So we want, in this case, we have the highest that our time can be in this problem is 45, but so this will be our upper bound when we use it in the calculator, but our lower bound is all the way to the left. So we're going to use, instead of positive 999999999, we're going to use negative 9999999 as the lower bound. Okay, so when you type that in as into your calculator with the lower bound being the negative 999 number and your upper being 45, then you actually end up getting 0.99 or 99%, a 99% chance. So then if you think about it, this is a lot of red shaded. And if you think about the example from part C, the previous page, that was 45 or more. So if it was 45 or more would be this little bit here which we found out to be 0.01, and then if you add on the rest of this over here, which is 0.99, then the whole probability, or the whole thing put together should equal 1.0 because that's all of the data. So that kind of just ties into the previous page. So the last question here is saying, if Amy races 80 times, how many of her races will finish in less than 36 seconds? Well, again, if we put it on the curve here, just think about it. So we have our mean in the middle, 39.7 again. And in less than 36 seconds, so 36 is somewhere over here, and we want to find the probability over here, so less than 36 seconds. So we have to find the z-score. So z equals, the 36 is our value minus the mean, 39.7, over the standard deviation of 2.3. So the z-score of being of 36 seconds exactly is negative 1.61. So we're going to find the probability that the z-score is less than, so less than the negative 1.61. And so our upper bound, the largest that we want it to go, is negative 1.61. And then the lower bound, since we're going to the left infinitely, is going to be negative 9,999, and so forth. And so typing that into your calculator, plug it in, and hit enter. The probability ends up becoming 0.053699. Okay, so this is the probability that it will be, that she'll finish in less than 36 seconds. But we want to know out of 80 times. So what we're going to do is think about this as, okay, well, this is really about 5%. If we move the decimal back 2 spots, that's about 5.4, if we rounded there, percent of the time. So we want to take our probability as a decimal, so the 0.05366 or 699, and we want to multiply it by how many races, so times 80 races, to figure out basically what is 5.4% of 80 races. And when you multiply there, you end up with about 4 races. So 4 races out of, if we interpret this and write it as like a sentence, out of 80, she will finish in less than 36 seconds. Okay? So, with that being said, why don't you go ahead and try some practice.